Hello, my dear students. Welcome to my today's online class on one more technique often used in biotechnology, that is RFLP, which stands for Restriction Fragment Length Polymorphism. Okay, so this is a slide giving my introduction that I am Dr. Meera B K, Associate Professor and Head, Department of Zoology, Maharani Science College for Women, Palace Road, Bengaluru 1. You can see my cell phone number and mail ID on this slide. After the class, any queries, do contact me over this. Now, so the diagram what I have put here will tell you the schematic happenings during RFLP. Okay, what all you are going to learn in next coming few minutes, all that has been summarized here. It is just a schematic representation of RFLP. Okay, now therefore I have highlighted this. Then what is RFLP? A RFLP represents a stretch of DNA that serves as a marker for mapping a specified gene. So basically, it is a stretch of DNA that serves as a marker for mapping a specified gene. Though definition wise it goes like this. Let us just try to understand in simple terms what exactly RFLP means. There are four terms in this. Restriction means the DNA fragments which have been subjected to the digestion of restriction endonucleases, and whatever the DNA fragments you get after the restriction digestion, that they are called restriction fragments. Okay, then its length. So the length of restriction fragments after digesting the DNA by using restriction endonucleases, and their polymorphism. Poly means many, morpha means appear, many forms. So in simple terms, you can take a genomic DNA and treat them with restriction endonucleases. Okay. So if there are n number of target sites in the genome, after restriction digestion, you will get n plus 1 number of DNA fragments. Okay. So they are restricted fragments, and their length varies from one fragment to another fragment depending upon the place of the presence of target site. Therefore, you get many forms, polymorphism. So that's what I exactly meant by restriction fragment length polymorphism. Okay. See, normally these RFLPs are located randomly throughout a person's chromosomes, and apparently they don't seem to have any functions. Now, you can cut a DNA molecule into different fragments by restriction endonucleases, and whatever the fragments outcome you get are called polymorphs. Poly means many, morph means forms, polymorphs. Okay. Now, let me explain this diagram. So, the diagram explains you an outline of RFLP. Okay. So, what exactly it tells us? Let us see. So, this is a DNA molecule. There are two DNA molecules, DNA 1 and DNA 2. You can make out in the diagram that DNA molecule 1 has three restriction sites, R1, R2 and R3. Alright. And when you cleave them with restriction endonucleases, you will get 4 fragments. I had already told you that you get n plus 1 number of fragments, where n is the number of restriction sites. Here there are 3 restriction sites, n is equal to 3. So n plus 1, the outcome is you will get 4 fragments. Okay. This is the fate of DNA molecule 1 after subjecting it to restriction digestion. Now you can see the bottom part where we have another molecule, DNA molecule 2. For our understanding, we have called it as DNA molecule 2. The difference is the restriction site 2 is missing. Restriction site 2 is missing. There are only 2 restriction sites. So, when you subject this to restriction digestion by making use of runs, okay, how many fragments you get? You will get only 3 fragments. Right? So let us consider that this DNA molecule 2 has an inherited mutation. Okay? Has an inherited mutation or a genetic change, and therefore has altered some base pairs. And as a consequence of this, the restriction site R2 is lost. So when you compare the products of DNA 1 and DNA 2, you can always say that there is a mutation in DNA molecule 2. This is what exactly is done in RFLP. This is how the analysis is done. Thus, a stretch of DNA exists as fragments of various lengths. That's what I meant by polymorphism, derived by the action of restriction enzymes. So hence the name RFLP. Okay. Now, same thing I have explained here. DNA 2 with an inherent mutation, therefore altered base pairs, and as a result R2 is missing. Therefore, when it is cut by restriction endonuclease, you get only 3 fragments instead of 4 as you see in DNA molecule 1. So this is what exactly happens in RFLP, and this is how analysis is done. When you look at DNA 1 and DNA 2, you can always say that in DNA molecule 2, there is some inherited mutation. As a result, restriction site 2 is lost. Okay. Then, so this is the dogma. Restriction site 2 is lost. Right. Then, there are 2 methods of detection of RFLPs. One, you normally do it by southern hybridization. Okay. What is done in southern hybridization? Basically, what is southern hybridization? It is a nucleic acid hybridization technique. Okay. So, in this southern hybridization, the DNA is digested with appropriate restriction endonuclease. You will get DNA fragments, and you can always separate out these DNA fragments by subjecting them to electrophoresis. And the electrophoresis type what we use here is H, agarose gel electrophoresis. Then the so obtained DNA fragments after H or after subjecting it to agarose gel electrophoresis, you can shift these DNA fragments to a nylon membrane. Okay, nylon membrane. Then a DNA probe that spans the suspected restriction site is now added, and the hybridized bands are detected by autoradiograph. I'll show the diagram little later in the next slide. So what you will do, you will take the DNA, digest it with appropriate restriction endonuclease, and then you will subject it to H. You will get so many DNA fragments that you will transfer it to a nylon membrane. And then you will add a probe. You will add a probe that spans the suspected restriction site. And hybridization takes place. And these hybridization bands, normally in southern blots, are detected by another technique called autoradiograph. I'll give you one homework. You can just make a note of your autoradiograph technique, okay, and keep as a supplementary reading to your reading on RFLP, okay. Then if the restriction site is absent, say for example inherited mutation or something else, then you will get only a single restriction fragment, okay. On the other hand, if the site is present, you will get two fragments. This is what happens during southern hybridization. Let us see the slide now. You concentrate on the figure A, okay. So the common methods used for RFLP analysis, this method A is by southern hybridization. You can see here a DNA piece containing three restriction sites, R1, R2, R3, right? DNA with restriction sites. Now for this what you will add? Restriction endonuclease, and then you can see at the place of R2 you have put a probe, right? DNA probe, right? Then the cut ones, the DNA fragments have been transferred to nylon membrane, and that suspected R2 site DNA probe is added, and it will hybridize with the bands here. So if restriction site is present, you will get two bands as you see here below. If the restriction site is absent, you will get only one band. This is how you will analyze the RFLP through the southern hybridization technique, okay. So let me summarize here. The DNA is digested with appropriate restriction endonuclease and then subjected to age. The so obtained DNA fragments are transferred to the nylon membrane, and then a DNA probe that spans the suspected restriction site is now added, and the hybridized bands are detected by autoradiograph. If the restriction site is absent, you will get one band as you are seeing in the diagram or the autoradiogram. Whatever you get, outcome of autoradiography is autoradiogram. And if the site is present, you will get two bands. This is how the RFLP is done through southern hybridization. Another method by which you can do is PCR, polymerase chain reaction, the technique I have taught you in my last class. Let's see what is done in this. For this, PCR primers that anneal on either side of the suspected restriction site are used, okay. Then after amplification by PCR, the DNA molecules are treated with restriction endonuclease, same step, and then analyzed by agarose gel electrophoresis, same step. If the restriction site is absent, only one band is seen. If restriction site is present, then you can see two bands. So same slide I have put here so that you can concentrate on the diagram B and compare with A. Okay, A for southern hybridization, B through PCR. Here you can see the same DNA piece are with restriction sites R1, R2, R3, and you are suspecting R2, right? Suspected site is R2. You will put PCR primers on either side of the DNA, okay, with restriction map. Then you will run the PCR. Then you will treat it with restriction endonuclease, then subject to agarose gel electrophoresis. Then you will go for hybridization, and if there is one band, it tells you that suspected site is not there. If you see two bands on autoradiogram, it tells you that suspected site is present, okay. So this is what is done in RFLP. Now let us see the applications. If the RFLP, that restriction fragment length polymorphism, lies within or even close to the locus of a gene that causes a particular disease, It is possible to trace the defective gene by analysis of RFLP, okay, in DNA. So what you have to do is, the person's cellular DNA is taken isolated and treated with restriction endonucleases. Then the obtained DNA fragments are separated by age. The RFLP patterns of the disease suspected individuals can be compared with same of normal people. So you have to repeat what all you have done for a suspected person, all that you have to do for a normal person, preferably the relatives in the same family. Okay. Then you can compare the band patterns of a suspected deceased person and a normal person. You can say whether the person has the disease or not. By this approach, it's possible to determine whether the individual has the marker RFLP and the deceased gene. Okay. So with 95% certainty, RFLPs can detect single based diseases. There are few success stories. Okay. And this approach is quite powerful and has helped many genes to be mapped on the chromosomes. For example, sickle cell anemia. They have come to know that it is on chromosome 11. Same way, cystic fibrosis on chromosome 7, Huntington's disease on chromosome 4, retinoblastoma on chromosome 13, Alzheimer's disease on chromosome 21. Okay, they are all single gene based diseases, and they have been able to spot out this particular position of these genes through RFLP. Okay. Now you can see this slide. Here is the DNA piece, okay, with restriction sites for MSTL, okay, and then this is another piece, right? So this is from normal person. This DNA is from normal person, preferably from the same family. This DNA fragment is from the deceased person. Now there are 3 restriction sites, and if there is a mutation, say for example, this mutation would have destroyed one restriction site. Now what all I explained, you have to do that. Treat with run, then run on AGE, then hybridize, right? So if you put them on age or gel electrophoresis, the band patterns you can see the normal and also disease. You can make out that particular few bands are missing in the deceased person, right? In the deceased person, especially the band here. So in the Southern blot analysis, you can compare the normal person's blots and the blot of deceased person. This is how exactly the bad genes are located. Okay, and you can just say by RFLP analysis whether the person carries a bad gene, whether the person will develop the disease. Okay, this is all about RFLP technique. My dear students, thank you for your patient listening. Any queries, do contact me. Stay blessed. Thank you. In my next class, I am going to teach 2 more techniques like this. One is RAPD and one is AFLP. Then we shall have a comparative account of all the 3 techniques, RFLP, RAPD and AFLP. Till those 2 techniques are over, you can just concentrate the reading of this technique. Stay blessed.